So we're here with Paul Bailey of Bailey Aviation, and this is your new baby, so introduce your new baby.
This is our new two-stroke engine called the Hornet. It's a two-cylinder, two-stroke, a bit unusual for us, and as you probably realise that we're well known for our four-stroke engines, but going down this route because we think there's a big market for it at the moment, particularly with the latest craze of slalom racing. So it's that's kind of what it's aimed at, slalom or the heavier end of the pilot.
And why is it better? Why two-stroke better than four-stroke for that?
It's just two-stroke. You'll always get better power-to-weight ratio, and the power is kind of suited to the slalom and that sort of competition, because it's very instant. The acceleration of the engine is very quick.
So you get a lot of power.
So
big boost.
It's a lot of power. You get most of the power very quickly when you ask for it.
So it's very responsive.
So it's very responsive. And being a two-cylinder, two small cylinders will always produce more power for the same cc than one big one.
Right.
So that's one of the reasons we're into two cylinders. The other reason is balance. A horizontally opposed twin cylinder has got perfect or near perfect mechanical balance, so we can have an absolutely smooth engine without the weight penalty of a balancer shaft.
Okay, so explain to me a little bit about the research and development that goes into developing something like the Hornet. I mean, when did you start?
We started the project in January.
Okay.
And it's basically been a full-time job until now. And we literally got this is the first engine, the first prototype, and we got it running last week. Okay. And I got a few days to do some test flights on it, and then we brought it here. So it was very last minute. We weren't sure whether we were going to get it finished in time to bring it here, but luckily. And
so you have test flown it. What's it like to fly?
I've test flown it. I've done probably 10 flights on it, and it's done quite a bit of time on the test rig. Initially, we're really pleased.
With the test rig, what do you do with the test rig? You just hang it up and...
No, the test rig is a thrust tester, and we can put all sorts of instrumentation on the engine, so we can measure temperatures, exhaust gas, cylinder head, RPM, thrust.
So give me some figures. I mean, bamboozle me.
We're not going to release any figures yet because the engine's still... It's a prototype, and it's at the prototype stage, and we expect to get more out of it as we test all the different variables that we built into it.
Okay.
And find the best combination of exhaust specification, compression ratio, gear ratio, and things like that. So the bulk of the engine is all UK made. The castings are made in Essex. We get the gears. They're made in the north of England, Chesterfield. The exhaust system we've made in our own factory. We made all the press tools to press all the exhaust parts out. They're not hydroformed; they're actually pressed, which is quite a lot more tooling. But the repeatability with a pressed out part is much more reliable.
So you make the mould and then you press it around.
Some of the parts are rotational moulded, the airbox and the fuel tank. The cooling system, the cowling, these ones on this engine are 3D printed, but they will
3D printed, really?
This is 3D printed, and they will be injection moulded, and it means we can test the cooling balance between the two cylinders. What we've got built into the cowlings is we've got several fences in there which we can either leave in or remove, so we can tailor the airflow. Once we get further down the testing road and get accurate temperature comparisons of the two cylinders, we can tailor the airflow. If we need a bit more airflow in a certain area, we can do it by removing certain internal fences, and then when we go to the injection mould, we can get the final version done with that already done.
So it's perfect.
Absolutely.
Yeah. And so do you do that, your 3D printing yourself, or you get that done in the shop?
we subcontract that out. Obviously we do the design. It's a 3D CAD design, and it's basically an email.
And you just email it?
Email file.
And then it comes in
and you get the part,
That's amazing.
It's modern technology, so makes the job so much easier.
You were showing me the starter earlier as well, because you've got something innovative there, haven't you?
It's got a spring in it, so you pull the handle against the spring, and the spring stores energy, and when that energy is enough to overcome the first compression, the spring takes the engine over the next 2 compressions, which is enough to start it. So
and you've done that in flight?
Yeah.
Yeah. Easy enough?
Yeah, very easy. The unique selling point of the Hornet is it's 2-cylinder, therefore it's very, very smooth. It has a gearbox reduction, it has a centrifugal clutch, so it's quite user friendly to operate, and being a relatively small capacity for the power, it means that it's very fuel efficient as well.